lot of time. So let's talk about titration so that as soon as class is over today, you can go work on those questions on the problem set. All right, so acid-base titrations. How many of you in high school titrated an acid with a base? Large fraction of you, okay. So usually what titration problems are meant to do, that you have some kind of something known about an acid or a base say of known concentration, and an acid of unknown concentration or maybe unknown molecular weight, and you're titrating them together to find missing information. So you can determine concentration. Sometimes you can determine a molecular weight. All right, so here's what a plot looks like and some of the key terms involved in acid-base titrations. So you have pH on one side and then volume of either base or acid added on the other side. So pH versus a volume. And the actual experiment here, you have a base that you're dripping, one drip at a time, supposedly, into here your strong acid. And then when you reach, then you're looking to figure out when you're going to reach the either equivalence point or the end point. These are basically the same terms. It's also called the stoichiometric point. And often equivalence point is used as a more theoretical, where the theoretical amount of volume is added, whereas endpoint is the experimentally measured. So we're going to be talking a lot about equivalence points because we have no lab associated with this course. So everything will be theoretical in terms of these. But they should be the same. So many times you will measure pH with a pH meter. This just shows a pH meter. And for those of you who have done these experiments, this should look familiar. And for those of you who haven't, often what you're doing when you're dripping something in, you're waiting for an indicator dye to change color as an indication that you have reached the end point. And often you're adding, and it's clear, clear, clear for what seems to be forever. And just as you get incredibly impatient, you start adding it faster, and you go all the way to this dark color. And what you want is this very, very, very light changed color that indicates the endpoint. So you usually go too slow and then go too fast and then have to do the experiment over again. Those of you who know how to calculate theoretical values could sit down and do a calculation first and then go really fast right until you get to around this point and add it really slowly and be done with lab sooner. So we'll talk about how you do the theoretical value, which could save you a lot of time if you ever run across these labs in any future class. So here are the two curves that you would see for either a strong acid with a strong base or a strong base with a strong acid. So if you're titrating a strong acid with a strong base, you're going to start down being very acidic because all you have is your strong acid. And then as you add in base, the pH will go up. You'll reach this point. S is for the stoichiometric point. We also call this, again, the equivalence point. And then it'll continue to go up and then start to level off a bit more up here. If you're going the other direction, you're starting with strong base, your pH is going to be high, and the pH will decrease as you add the acid, and then you get to the stoichiometric or equivalence point in the middle of this curve here, and then as you go down farther, more acidic, it starts to level off. So those are what the titration curves look